Hi folks, today we're going to talk about finding holes in graphs. This is something that doesn't necessarily have to happen in a graph. Some graphs might have holes and some might not. But I'm going to show you how to do it. It's very easy, very straightforward. You just have to follow the steps. And it's actually one of the first things you're going to do. So I know we already talked about finding x-intercepts and y-intercepts and vertical asymptotes and horizontal asymptotes. So this is going to kind of fit in right in the beginning before you do those different things. I'm going to walk you through step by step how you would do it and how the whole thing works. So what you want to do is you want to always look for a common factor in the numerator and the denominator, which means the first thing you're ever going to do when you have a rational function is to factor it wherever you can. So if I go ahead and factor this, I can factor the numerator and I can factor the denominator. When I factor the numerator, I end up with x plus 2 times x minus 3. Oh, I'm sorry, it's the other way around. Hold on, messed up my signs there. Would be x minus 2, x plus 3. Because I have to add to positive 1. Okay, and then in the bottom, this is difference of perfect squares. So that factors to x minus 2 and x plus 2 for my parentheses there. So here's the idea. What I want to do is I want to cancel my common factor. Okay, so when I cancel my common factor, I'm getting rid of x minus 2 in the numerator and x minus 2 in the denominator. And what that leaves me with is this function x plus 3 over x plus 2. So this is you'll sometimes hear it referred to as the reduced form or the simplified form of the function. This is going to help me to find the whole. Okay, but the first thing I'm going to do is figure out what the x-coordinate of the whole is. And that comes right from this here. When I set that common factor that I canceled out of the top and the bottom, I'm going to set that equal to 0 and solve that. And I'm going to get a value for x. That's the x-coordinate of the whole. Okay, so this is the x-coordinate of the whole. So because I was able to cancel a common factor, that means I'm going to have a whole. Okay, so when you can cancel something in the top and the bottom, you will absolutely have a hole in your graph. So my whole, I know that the x-coordinate of my whole is going to be 2. And now I just need to find the y-coordinate because the whole is just a point, right? That's it, a hole in the graph. So it's a point when you're finding the whole. So now in order to find the y-coordinate, all I'm doing is taking this value and plugging it in to figure out what the y-coordinate is. So basically, I'm finding f of 2, meaning in this function up here, I'm plugging 2 in for x. So I have 2 plus 3 over 2 plus 2, which gives me 5 over 4. And so let me do that in red. And so my whole is at 2 comma 5/4. And what that also means is that I do not have a vertical asymptote at 2 because I've canceled that out. So the idea of a whole is that where you would have had a vertical asymptote, if you couldn't factor and cancel stuff, now you have a whole because you can factor and cancel stuff. So I'll show you some examples of where you might have a hole and where you might not have a hole. We'll go through a few examples so you kind of get the idea. If I look at this first function up here, the first thing I'm going to do is I'm going to factor it. Okay, so when I factor it, there's nothing to factor in the numerator, so I just have 2x squared. However, I can factor the denominator. So I have x minus 1 and x plus 1. Now, because there is nothing that I can cancel out of the top and the bottom, I have no holes. Okay, because in order to have a hole, you have to have canceled something. But since I have no holes, that means I will have vertical asymptotes at x is equal to 1 and at x is equal to negative 1. Okay, so that's the idea. If once you factor it, you can't cancel anything, then you have no holes. You take everything in the denominator and set it equal to 0 to find your vertical asymptotes. Okay. If you have a hole, then where there's a hole, there will not be a vertical asymptote. Let's look at the next one. So first thing I'm going to do is I'm going to factor. In my numerator, when I factor that, I end up with x plus 2 times x minus 1. In my denominator, I have x plus 2 times x minus 3. So, because I have common factors, I'm going to have a hole. I'm canceling my common factors, so I'm left with x minus 1 over x minus 3. And now I'm going to figure out where my hole is. I already know what the x-coordinate of my hole is. I just set that factor that I canceled equal to 0 and solve it. So the x-coordinate of my hole will be at negative 2. And now I need to find the y-coordinate. So I'm just going to plug negative 2 into this function here. So I have negative 2 minus 1 over negative 2 minus 3. So that gives me negative 3 over negative 5, which reduces to 3/5. And so my hole is at negative 2 3/5. Now watch here for a second. My vertical asymptote, the only thing that I have left in my denominator is this x minus 3. So my vertical asymptote, I only have one, which is at 3, because now I have a hole. Okay, so once you have a hole where you would have had a vertical asymptote, then that asymptote disappears. So I will not have a vertical asymptote at negative 2, but I will have a hole at negative 2 3/5. Let's go ahead and do one more. There's nothing to factor in the denominator, so I'm going to go ahead and factor my numerator. When I factor that, I have x plus 3 times x minus 1. In my denominator, I have x plus 3. And so here, my x plus 3's will cancel, and so I'm just left with x minus 1. Well, now that I've canceled everything in my denominator, I will not have a vertical asymptote because I no longer have a denominator. However, I will have a hole because I canceled common factors. So my hole will be at negative 3 something, right? Because all I'm doing is setting that factor that I canceled equal to 0 and solving it. So I get x equals negative 3. So that's the x-coordinate. And now to figure out the y-coordinate, I just plug that negative 3 in here. So I have negative 3 minus 1, and that gives me negative 4. So I now have a hole at negative 4. So that's how you find holes. We're going to talk about this more in class next time, but there will be an assignment on finding holes. We're going to talk about how that fits in to everything. We talked here about how it fit into the vertical asymptote and how it affects your asymptotes. We'll talk about how it affects horizontal asymptotes and x and y intercepts and all of that next time. Next time we're going to go through the whole process of graphing a rational function. So thanks everybody. We'll see you next time. Bye-bye.